Example 9.4.1, ranking projects based on PI or profitability index. All right, so before we go through the setup for this one and actually working through it, I just want to talk a little bit about profitability index and when we might want to use it and when it's helpful for us. So examples we've looked at before now have all been net present value, internal rate of return, and when those two together can give you more information, which is almost always, and when you might want to rely on net present value instead of internal rate of return because of the issues with internal rate of return. Now we're going to look at some other investment decision rules, this first one being profitability index. And profitability index comes in handy when we have multiple positive net present value projects that we might want to invest in. And remember, the net present value investment decision rule is we accept any positive net present value project. Well, a lot of times we might have multiple projects that we could invest in, but because of capital constraints, we can't take all of them. So what we want is a method that will allow us to select the combination of projects that we can afford that will give us the highest possible combined net present value. And profitability index helps us do that. It helps us rank the projects based on sort of a bang per dollar invested measure. And then we can rank order them and say, we'll take the highest profitability index project first and just work our way down the list until we run out of capital to invest. Now, things can get a little strange at the end if we've got multiple projects left and one is actually more attractive based on net present value or internal rate of return, but we don't have enough capital left to invest in that one. And that's what we'll see in this example. So let's walk through this setup. This one says that your firm has $1 million available to invest and has identified the following 4 potential projects and assume, well, we've got a note here, assume that each has the same expected lifespan. So we sidestep some technical issues here. All right, and we've got 4 projects, and we've labeled them projects A through D. We've got the cost to invest in each project listed there as a negative just to indicate that it's cash outflow, and then the expected net present value of each project. So we don't have to go through and actually calculate that. It's already been done for us. Now we can see here that all 4 projects have a positive net present value. The NPV decision rule says to accept all 4, but the total cost of investing in all projects is higher than what the firm has available. Right? If we look at these costs, just projects A and D together, A is $500,000, D is $390,000. We're up to $890,000 there, and we only had $1 million to start with, so we can't take all 4 projects. We've got to figure out which ones we want to take. So the question is, which combination of projects can the firm accept that will offer the highest total expected net present value, and what is that highest total net present value the firm can expect given the limited budget? Okay, so we're going to use profitability index to rank these guys, and profitability index is defined as, this is a definition. There are several different ways that profitability index might be used, so if you're using it in an industry-specific context, it might not be exactly this, but the general idea will still be the same. For us, we're going to define it as net present value divided by resource consumed. All right, so NPV is our measure of return for the project, and the resource consumed, in this case, that's going to be dollars that we're investing in the project. So we're going to get a rank of NPV generated per dollar invested. That's what profitability index is going to give us back. So let's do that for each one of these projects. We'll just take them in order. Project A has an NPV of $75,000 and a cost of $500,000. So if we put that net present value over the resource consumed and divide those out, we'll get a profitability index of 0.15. Right? And the way to interpret that is, for project A, for every dollar we put in to the project, we're getting on average 15 cents back from the project in net present value. All right, project B had, if we look at it, a cost of $90,000 and an NPV of $9,900. So if we take that NPV divided by the cost, we'll get a profitability index of 0.11. Project C had a net present value of $22,500 and a cost of $200,000. So when we do that division, we'll get a profitability index of 0.1125. And then finally, project D had an NPV of $45,400 and a cost of $390,000. So when we do that division, we will get a profitability index of 0.1164. Right, now what I like to do when I work these problems is I'll just add the profitability index to the chart. at the bottom so I can keep track of it a little bit easier. Just visually, it makes more sense to me. All right, and now we can easily see with these, based on this sort of efficiency measure of profitability index, Project A is the most attractive. Project D is the second most attractive because it has the second highest profitability index. Project C is the third most attractive, and Project B is the fourth and last most attractive. Now here's the issue we'd run into. So what the profitability index is used for is we'll rank the projects in order like that, and then just work our way down, starting with the highest profitability index until we run out of capital. So let's look at what happens. We'll take Project A first because that's our highest profitability index, and that's going to cost us $500,000. And remember, our original budget was $1 million. So if we take $1 million minus $500,000, then we have $500,000 left to invest after accepting Project A. And the next most attractive project is Project D. It has the next highest profitability index, and it has a cost of $390,000. So we have $500,000 left. We can accept Project D, and we would, right? And then after we take that $500,000 we have left, subtract out the $390,000, we now have $110,000 left of that original $1 million to invest. Now here's where we run into a bit of an issue. Project C is the next most attractive project in terms of net present value generated per dollar invested, because it has a higher profitability index than Project B, but it would cost us $200,000 to invest in Project C, and we only have $110,000 left. Right? But we don't necessarily have to stop there, because when we look at Project B, it's still a positive net present value project. We have $110,000 left to invest. This project's only going to cost $90,000, so we can take that project on and earn that additional net present value of $9,900. All right, so if we do that, we've got $20,000 left that we could invest, but it's not enough to invest in any of the remaining projects. All right, so we're done at that point. We've used up the capital that we can with the projects that are available. We've selected the highest possible profitability index projects based on the budget. And so to find the total expected NPV of those three projects, we just add up the NPV of the ones we accepted, which were Project A at $75,000, then Project D at $45,400, and then finally Project B at $9,900. And if we add those three together, we'll get a total net present value generated of $129,400. And so that's the answer to this question. We should select projects A, B, and D, and then the total net present value from these three projects is the $129,400. Now, profitability index is kind of a shortcut to be able to figure that out. With only 4 projects, you could also just sort of game this, figure out which combination of projects you could afford with the $1 million budget, and then just play with the net present values until you find the highest possible net present value you could earn. But you're always going to come up with the same answer that you're going to get by ranking them by profitability index, and then just starting at the highest profitability index and working your way down until you use up your budget. So this is something of a shorthand method for getting to the most efficient answer, that is generating the highest net present value possible given the budget that you have and the projects that are available for investment.